All right, so here we go. Let's go ahead and take a look at number 10. And hopefully by now you're starting to see the pattern of what it is that we're doing. We are factoring each numerator and denominator as much as we can, and then taking a look to see if any of the factors cancel. And once we've canceled everything that we can, then we go ahead and perform the indicated operation. So let's go ahead and jump in and see what we have. All right, let's go ahead and factor this numerator here. So we have x squared plus 6x plus 5. Is there a GCF? Nope, don't see one. So question number 2 that we ask ourselves when factoring, how many terms? Well, 1, 2, 3 terms. So we're either using the AC method or the scissors method or trial and error. But again, because this is a 1 in front of our squared term, let's go ahead and use the simplified version of scissors. And it's also the simplified version of the AC method, where we're just taking factors of 5, and we're looking for factors of 5 that add to positive 6. Well, we know this is going to factor into a binomial, and we're working with x, so let's go ahead and split that x up. And now what factors are we dealing with? Well, let's see, factors of 5 that add to positive 6, I think plus 5 and plus 1, right? 5 plus 1 gives us the positive 6, and 5 times 1 gives us that positive 5, so we're good there. All right, now let's take a look at this denominator. Let's see, we have a GCF of, looks like x squared, right? So let's factor out that x squared, and then we're going to be left with 5x minus 6, and then times, let's see, what's our GCF here? Looks like just an x, and which leaves us with 25x squared minus 36 all over, and let's see, what's our GCF here? Looks like just a 6, so we'll take out that 6, and that leaves us with x plus 1. All right, now you might have been screaming at the at your computer screen or your phone, whatever you're watching on, saying, wait, we can keep factoring this, and you're right. 25x squared minus 36 you may recognize as being the difference of perfect squares, right? And so 25x squared minus 36 factors into 5x plus 6 and 5x minus 6. So let's go ahead and we'll get rid of our 25x squared minus 36, and instead we'll replace it with that factor there. All right, so now we've factored each numerator and each denominator as much as we can. So let's go through, and now comes the fun part, which is now canceling everything that's common. So let's see. Well, and again, before we start canceling, just as a refresher, remember you can cancel up and down, and you can cancel diagonally left to right or diagonally right to left. You cannot cancel left to right, so do not cancel left to right. But let's see here, x plus 1, well, that's diagonally, so we can cancel diagonally, so that's gone. We have a 5x minus 6, gone. We have a single x here, and that can cancel with one of our powers there, so that squared is gone on the bottom. And I think that's about all we can do. So once we've simplified as far as canceling is concerned as much as we can, that allows us now to perform the operation that's indicated, which in this case is multiplication. So we're going to have the quantity x plus 5 times the quantity 5x plus 6. So x plus 5 times the quantity 5x plus 6. And that's all over just 6 times the single x, so 6x. And now you can do one of two things. You can either leave your answer just like this, which is perfectly acceptable, meaning leaving it in factored form, or you can go ahead and take your numerator in this case and FOIL these two binomials together to get one trinomial. Either way, you will be just fine. But leaving it like this is probably the easier option, right? Obviously, because you don't have to go through this foiling. And because even if you were to FOIL this, nothing is going to cancel with this 6x. That's a reason that we can go ahead and end here. But whatever you're more comfortable with, or if your professor has a preference one way or the other, then definitely make sure you're doing what it is that you're being asked. All right, so there was number 10. Let's go ahead and take a look at number 11.